draws from a lot of things you already know. The bad things is if you don't remember what you did in previous years, then you're in a bit of trouble, but nothing that you can't overcome with a little bit of work. So just remember, guys, when it comes to geometry, you can still use sine and cosine law. That's why I like this unit at the end, because it reviews that as well. Okay? You remember Pythagorean theorem?
Oh, yeah.
Yeah, I'll just briefly go over that. I'll just say this. Don't use SOHCAHTOA. I know some of you have like a hard time with that. You're like, oh man, those were the good old days, right? SOHCAHTOA all day. You can't use that and don't use it anymore. Okay? If you get into plumbing or carpentry, most of those industries, they use SOHCAHTOA again because a lot of right angles appear in those industries. Okay? But if there isn't a right angle, you should not be using it. Okay? I will just say flat out, don't use it. Always revert back to sine law and cosine law. That's it. All right. What's this unit all about, folks? It really breaks down into the three things down here. We're going to talk about triangles. Then we're going to talk about quadrilaterals. Triangles have how many sides? 3. 3 angles, 3 sides. Quadrilaterals have 4 sides, 4 angles. Polygons, what does that mean? Many sides. So anything, technically polygon has everything under it. But if it's more than 4-sided, then we just go polygons. Like it's like pentagon, hexagon, heptagon, like all those gons are going to be covered next. So this is the progression that we're going to take, all right? So let's start our journey here. Review prior skills. You need to know about symmetry and when it's not symmetric, okay? An isosceles triangle and an equilateral triangle can split in half because they are symmetric. How do you know a triangle is either one of those right off the bat? You look at sides or angles. Do you see that? Do you see that this is 50 and that is 50? Do you see that? Markings go like this. That side is the same as that side. And this is 80, of course, right? So this is an isosceles triangle. Right? You can split it. Split, no problem. Mr. Dixon, what does that mean? Why is that so important? Because some of you do that no matter what, but you can only do it if it's an isosceles or equilateral. So if this is 70 up top here, I can split that in half and get 35, right? So I know that this is 35 and this is 35. That's what I mean by that. So sometimes that's going to come in handy. Okay? So bringing this 35 over to here, right? If you were to have a right triangle, all right, let's keep going. And we're assuming, okay, like I'm going to be very specific with this, especially on a quiz or on a test. Like if there's a 90, you can obviously bring that in here. So this is the half that you split, right? This is H. And obviously, what can you do now? Can you find the third angle of a triangle? If you have 2, absolutely. So to get this one, you just go 180 minus 90 minus 35, and that gives you 45. So it's like it's like a chain reaction. If you have a little bit of information, right, you can find everything else. So this is the sum of a triangle is equal to 180 property that I've used here. What about the side lengths? I've done everything with angles. This 50 stays 50, correct? What about the 80? Can I split that in half? Yes, you can. In this case, you can split that in half. So this side is 40 centimeters, this side is 50 centimeters. So now you have a triangle that has a lot of info. It's a beefed up triangle there. And just remember that in this case you can split it. You can. And that means the angle up here, the 70 turned into 35, the 80 turned into 40. So splitting is fine. Cutting it in half is fine. Listen carefully. What if this had been 60 here? 50, 60, 80. No longer isosceles. No longer symmetrical. You cannot assume that if you split this in half that it'd be 35, 35. You cannot. Okay? That's what I'm also saying with this example. Right? This one. What kind of a triangle is this one? 100, 100, 100, right? So this side is the same, this side is the same, this side. This is, yes, equilateral. You can also split that one. No problem. Anybody know what the angles are of the equilateral triangle? What is the measure of an equilateral triangle? If you have 180 degrees split into 3, 180 degrees, you split it into 3 angles, you get, it's always going to be 60, guys. It doesn't matter how big or small the triangle is. If all 3 sides are the same, this is 60, this is 60, and so is this one. Always. That's equilateral triangle, boom, you know it's 60. Like without even doing any math. You don't have to use sine law, cosine law. You just know it's 60 all around. So if you were to split this down the middle, okay, what would we have? What would our resulting triangle? We would take the 60 and divide it in half. That would be 30. This 90 here, we don't split in half because 90 stays 90. And then this 60 here also gets split in half to give you 30. I made a mistake, right? I was like, what is wrong? This can't be. Does this add up to 180? 30 and 30 is 60 plus 90 is 150. Can't be. I shouldn't have split this one. That stays 60. Sorry, my bad.
There you go.
I just want you to like catch yourself. If you make a mistake, you should be able to catch your mistake. Okay. And this 100 gets split into half as well. Okay, the 100, you split that in half. So this is 50 centimeters. The 100 stays. That just stays, nothing changes there. And boom, you've got now a triangle there that you can possibly work with. Okay. This one here, is this one symmetric? It's asymmetric. Can't split, okay? You cannot do what we just did up there. You're kind of stuck. Could you use cosine law perhaps in this one, right? Side, side, side. Yes, you could, but that's above and beyond. We're not going to go there right now, okay? So that's, I'm just trying to, I honestly gave it way too much, a whole page for this, but students often split when it cannot be split, okay? So let's keep going. Some formulas, go to page 3 here. I'm just going to ask you to have these formulas on your study sheet because they're not on your formula sheet. Okay, so add to study sheet. And at this point, you may fill up your study sheet right, like fully loaded, right? Like as you get through this unit, just use up your space. as much as you have to. You're good to go now. Okay, let's keep going. So page 3, that's all I'm going to draw your attention to those formulas. Hold on. Do I need to clarify? Area of a trapezoid. Watch this one. This one comes in later. A trapezoid looks like this, but in general, but it could also look like this. It could be a cutoff version like this. So you can do or. It could also just look like this. And I guess now that I'm looking at it, the height is not labeled on your diagram, but guess what? The height is right there. That is the height. And on a trapezoid like this, guess what? The side of the trapezoid is also your height. So A is the shorter side up here, B is the base, and H is just quite simply the side here that you found. So add that to your study sheet to make sure you have that. So that's to find the areas of those shapes. That's all. Let's keep going. Okay, I'm going to teach you a Pythagorean theorem. It's a crash course. This is probably different than most teachers have taught it. I don't like ABC. Okay, ABC to me it's very confusing. Where's AB, where's B, where's C? Instead, Pythagorean theorem is the hypotenuse squared is equal to one of the legs squared plus the other leg squared. So the hypotenuse is always across the 90. If you find a 90, go to it, travel across, that's the hypotenuse. Across the 90 degree, it is also the longest side, correct? Always. So a couple of giveaways there. This is a leg, this is a leg. So the other two are called legs. The hypotenuse is the easiest one to find across the 90. The other ones are legs. Okay. So Pythagorean theorem only works with right triangles. You need 2 out of the 3 sides or else you cannot use it. Okay. So 2 cases here. If the hypotenuse is unknown, we use this one, this formula. So let me just flip my page. I want to make sure I have that right for you. I would just go to figure out what the hypotenuse is. We take the square root of leg squared plus leg squared. That's it. That's it. That's how you find the hypotenuse. If a leg is unknown, if out of the 3 sides you're missing one of these legs, okay, then this is how you find it. Leg is equal to square root of, and here the order matters. You have to take your hypotenuse squared, subtract the leg that is known, but make sure you square it and subtract it, and then take the square root, and boom, you got it. So under, I'm going to just say Pythagorean theorem, I would just have these 2, to be honest. Unless you need that diagram up here, then go for it. But make sure you have Pythagorean theorem. It has to be a right triangle, okay? Or else it doesn't work. You don't need it a whole lot, to be honest, but if it does show up, every once in a while it comes in handy. And I'm going to get you to jump in the water right away and try that with the 2 examples below. What are you missing in this particular sample right here? This is the 90. Travel across. The one that is unknown is your hypotenuse. Don't call it A, just call it the hypotenuse. You're looking to solve for the hypotenuse here. Okay? Go to the bottom here. You go to your 90, travel across. This is the hypotenuse, which is known to me. So what am I trying to find in this one here? You're trying to find one of the legs. Yes. So use the formulas and figure out what they are, please. I'm not going to spend a whole lot of time on that. You'll get a chance yet to practice a bit more. This case here, the hypotenuse is going to be equal to 7.6 squared plus 9.4 squared, right? Which makes the hypotenuse, if you just do this part, you should all have a square button, right? X2 it is for me. You can actually type it in all in one shot. So it's 146.12. Make sure you show work, right? And then you take the root of that, and that's 12.09 centimeters. So there you got it. Here, you're trying to find the leg. So to find the leg, you want to go, I'm going to write out the formula here. Hypotenuse squared minus leg squared. So the hypotenuse is 17.8 squared minus 12.6 squared. Let's figure out what that is. It's 158.08. Taking the root gives you 12.57, what are we in, inches. It's very close to 12.6 if you think about it. If you rounded it to 1 decimal. But that's besides the point. Everything is rounded to 2 decimals, except for when it's talking about, right, how many people, all of that, we want to round to a whole value there. As well as percentile rank. Remember that? No decimals there. Okay, keep going. I'm going to skip the rest. This is what today's is all about. This is the, you know what? It's not new. It's not new, but go to page 6 here. Working with triangles. Naming triangles, okay? I want you to know that all triangles have 3 sides, is a closed figure, and the sum of interior angles is always 180 degrees. This is where I need to make sure you understand. If I ever ask you to classify triangles, it basically asks you to name triangles. Okay? Name triangles. Naming triangles, if you want to call it, right? That's what you're doing when you're classifying. You're giving it a specific name. Okay? When a question asks you to classify a triangle, you're being asked to give it a first and a last name. That's what I use to make it a bit catchier. A first and a last name. So every triangle technically has two names associated with it. We don't always do that. Okay? So this is going to be the first name, and this is going to be the last name. Okay, so you can kind of think of it as first name and last name. So listen carefully here. The first name is when we look at the angle measure. Okay, angle measure. So let's highlight that. The first name is is going by angle measure, and the last name, we're looking at the side lengths. So you look at a triangle, okay, and you will make an observation. Which one of these 3 categories does it fit into? There's only one. Okay. Is it acute? Right? All 3 angles are less than 90. You know it's going to be in this category. It's going to be called an acute triangle. If you have 190 degree, right? So this one right here. If you see the 90, you don't even have to bother with the other 2. It's immediately going to be the right triangle. Like, don't even bother with the other ones. Obtuse is if one angle is greater than 90. So this one right here. This is definitely bigger than 90, right? So that's the one it immediately turns into an obtuse triangle. You don't even have another choice, right? So if you notice, oh, this one is 120, boom, it's going to be obtuse. If you notice that this triangle has a 90, it's right. If you notice that they're all less than 90, that's your only other option. It's going to be an acute triangle. So this is the first name. Then the last name. We're looking at the side lengths. Equilateral when all three sides measure the same. Isosceles when two sides are of equal length and two angles are of equal measure. Okay. Scalene, all sides are different and no angles are of equal measure. Okay, that's what you need to know. Now, I'm going to make you a big note here. Write it down on the side. Note. Make sure you write this one down. It's going to help you a lot. Okay? It turns out that if we know all three angles, we can also classify by side length. As well. This is a huge side, which I would definitely add. Okay? If we know all three angles, we can also classify by the side length as well. You actually don't need to know a single side length number-wise if you know all three angles. I'll show you that in a bit as we go through the examples that follow. So today, the main idea is to classify, to give every triangle a first and last name. If you can do that with a little bit of work, you're golden. You're good to go. One last thing here at the bottom of this page. Sometimes the province will pick your brain. Okay? It says, why can't a triangle have more than one obtuse angle? Explain. Like if province ever does that to you, it's like, why is that? Well, let's consider a triangle ABC. Let's say that A is going to be, angle A is 91 degrees. And angle B, that's an obtuse angle, correct? You're with me, right? Let's make B obtuse as well. It's angle C. What's the problem? Anybody notice what the problem is if we have a 91 and another 91? What do we have there? What does this add up to already, the two angles? 182 degrees, right? This cannot be. Since all three angles have a sum of 180 degrees. Okay? If you ever have a question like this, use diagrams, use examples, and write a little something to make your point. Okay? You don't have to just write. You can also use diagrams. This would be justify, explain, right? That type of question. You may go with that. Okay, back to naming. Okay, back to naming now. Go to page 7. Let's look at the steps here. These steps may look overwhelming. It may look overwhelming right now, but as we go through the examples, it's just gonna be the thing you do anyways. This is on page 7. Steps to classify. Look for side lengths or angles given. It could be markings or actual values, by the way. Just look at it, right? Step 2. Are you able to determine all 3 angles using the sum of triangles equal to 180? If yes, listen carefully. If the answer is yes, you have everything you need. You can classify, just name it. If you're able to get all 3 angles, you're golden. Don't find another side. If not, right? If the answer is no, do you have a pair or is it a side, side, side? Use trig to determine the rest. Note, for side, side, side cases, only check if the angle across the longest side, right? Only check the angle across the longest side and see if a squared plus b squared minus c squared is positive, 0, or negative. And you might be scratching your head right now. What is this? Like, where is this coming from? Remember the formula? Cosine of c, for example, would be a squared plus b squared minus c squared over 2 times a times b. Remember that one? So you just want to check this top here, because remember, do you remember that this could be negative? The top could be negative, which tells us our angle is going to be obtuse. If this thing is positive, we know that we're going to have an acute angle across the longest side. And if this ever ends up being exactly 0, it's a right triangle, by the way, folks. So these are your 3 options here. I will give you a disclaimer because we're so close to the exam. This third piece here is very rare. So technically, that's all you're going to need to know the first 2 steps, to be honest, 99% of the time. So this, I will show you yet how I'm going to use this, okay? All right, you're still with me, right? Here we go. Classify. So basically name it. The following triangles by side length and angle measure. Remember, let's just do a side thing here. If it's by angle, if it goes by angle, sorry, you have acute, right, obtuse. Just write this down real quick here. These are your 3 options if you go by angle. If it's by side length, you have equilateral, isosceles, and scalene. Scalene is the one where nothing is the same. Yeah, so these are your, you've got 3 options on either, for the first name, 3 options for your last name. And the order really doesn't matter if you want to switch up first and last. So let's look at this one. In terms of angle, which one does this one qualify? Which one of these 3 categories? It's a right. So you'll say right. Because of this, boom. When it comes to sides, which one of these 3 are you going to pick? Mr. Dirksen, there are no numbers. Thinking isosceles? You see the markings? 1, 2, and 3. It means that none of these measure the same. They're all different. Okay? So this one would be scalene. Yeah. Right scalene. So this triangle is a right scalene triangle. Mrs. Dirksen, what if I mess up on the test and I say scalene right? 100%. You still get 100% of the marks. The order doesn't matter. So if that throws you off, don't worry about it. But because all sides different, okay? And how do you know that? Look at the markings in this case. There were no numbers. So boom, you've got it. Okay, next one here. In terms of angle and the side, let's see. What does this tell me about the angles? They all have just one marking like that. That means they're all the same. What does that tell me? What is the only option of them all being the same? 180 divided by 3. That gives me 60 degrees, right? So I know that these are all 60. And that actually gives everything away right now. In terms of angle, which one of these three are you going to pick? Acute, yeah. In terms of side, remember I told you when all three angles are given, you actually can figure this one out too. It's equilateral. Because if all three angles are the same, guaranteed all three sides are the same. Guaranteed. There's no, like, you don't even have to guess. So you can actually go ahead and, if you have a different color, just say this one is the same as this one is the same as that one. Okay? So you can conclude that. You didn't have to. If you just give me the name, you're good. But you could have gone back to the triangle and put the markings down. Okay? Let's keep going. Are you having fun yet? I know this isn't everybody's cup of tea. I know that, but it's actually, don't overthink it. That's all I'm going to say to you. Don't overthink it. Let's name this one. I'm just going to put 2 lines now. In terms of the angle, it's a right. Because this is right, this is a right. So based on what we're given, we know for sure this is a right triangle. Because of this, boom, you have no option. It is a right triangle. And look at it this way. You cannot have a right angle and an obtuse at the same time. Because a 90 plus 91 is what? 181 already, like you're over. So you can't have an obtuse yet on top of a right. What about side length? Let's think about this. These two are the same, correct? So we're in the isosceles category. This one is longer. This is the longest side. This is the longest side here. Because the 90 is across from it. And remember, that's the hypotenuse. So this is the longest side. This one will not be able to be the same as these two, even if you tried. So this is an isosceles because of the markings. So maybe I'll just highlight the markings. That is what gave away this part. And the 90 degree gives away this part. Okay, let's say you're absolutely 100% stuck. Please don't leave this blank. Even if you get one of these right, you could still score partial marks. So just give it your best. Okay. One last one here. No markings. I'll make a note here. No markings. Do you notice that? Okay, so how do we approach this one? I hope that if you see 2 angles, it should just urge you to find a third one. That's the first thing that I would like you to do. Let's find this guy right here. We're going to go 180 minus 30 minus 20. What does that give us? 130. Okay. Believe it or not, you don't have any side lengths, correct? You cannot solve this anyways. Like, this is unsolvable. But can we still name it? Absolutely. If you look at all 3 angles, which category does this fit into? Acute, right, or obtuse? Obtuse. Thank you. Thank you. Hey, we're all kind of like, I don't know, I don't want to mess this one up. Right? Because of the 130, I know it's obtuse. And looking at the angles, they're all different, correct? What does that tell me about the angle, the side lengths? They will all be different as well. Remember that. So what category am I going to pick between the 3? It's going to be scalene. Scalene is the one where everything is different. So I go back here and I call this scalene. And I will say this. The reason I did that is all angles are different. If you're wondering, like, how did Mr. Dirksen end up with that second name there, the last name, it's because I make an observation that all angles are different. Can you be with me one more time? A different scenario. If this had been 30 and this had been 30, what kind of triangle would it have been in terms of side lengths? 30-30, not 30-20, but 30-30. Isosceles. Because if you have two angles that are the same, then the two sides that are across from them are also the same. Easy peasy, right? Not so much. I'm not saying this is easy. I'm saying this is doable, right? Okay, go to page 8. Give this a try. Every single one on here. If I could give you $100 for every right answer, if I could you do it? So try page 8. Talk to a neighbor if you have to. Try page 8. First and last name. Fill in what you can. Fill in what you can. And then just go from that point on. Okay? Let's go over it real quick. It shouldn't take you that long after a while, all right? What about this one? Do you notice the markings? It's isosceles for sure. Yeah. Can I just pay attention to this part, okay? If these two sides are the same, right? And this side tells the other side, hey, I've got a 25-degree angle across from me. What do you think this side is going to say? Hey, guess what? There's also a 25 across from me. Guaranteed. Hey, you've got two angles now. Can you find a third one? You betcha. So this is the first step I want you to observe. So we're going to go 180 minus 25 minus 25. That's that 130 again? It seems to be like 130 is the number to go with here. However, once you fill this out, if there are numbers, you may be able to fill it in quite a bit, making your job easier. So in terms of the angle, it is obtuse. Because of that, right? It's bigger than 90. One angle bigger than 90. So you have to go by that. There is no 90, so right angles out of the question. You don't have all of them less than 90, so acute is also not an option. It is obtuse. Next, in terms of the side lengths, Mr. Dirksen, I don't have a side length, so I can't do it. Wrong. Okay? You're going to go by either the two angles or the markings, whichever is your preferred method. The markings is the easiest way to go about it, but it's an isosceles triangle. Okay? Two sides are the same, congruent. Did I ever do that symbol with you guys? That's a symbol for congruent, the same thing as being the same. And two angles are congruent. That's why we know it's an isosceles. Okay? So if either one of them had been in the picture, you would have been able to name this. Whether it's the two sides being the same, or whether it's the two angles, you observe two angles being the same. My fingers are too big, they block everything. Anyways, what about this one? Oh, it's isosceles, Mr. Dirksen, because I can see the markings. You are probably right. You are most likely right. However, pay attention to this one, because my lesson is also discovering new things. Do we know that these angles are the same? Yes, because this side and this side, they have, both of them are the same measure, so we're guaranteed that the angles across from them will also be the same. Got it? Can we potentially find out what they are? Yes. 180 minus 80, this one here. We take that then and we split it in half. So that would be 100 divided by 2. That is 50 degrees split in half. So this is 50 and this is 50. And let's check, right? 50 and 50 is 100 plus 80 is 180. So we're actually okay. And so was it necessary to do this? I would say no, not in this case, but I'd like you to just do it anyways. So based on angles, what category is this in? Well, they're all less than 90. So it's an acute one. So cute. And in terms of side length, I have two angles that are the same, but I also have two side lengths that are the same. Either one works. Isosceles. So tomorrow that's your AC, right? Just to name them. Just to name them. Let's keep going. What's this one? In terms of angles, this one you should pay attention to this one. Does this look obtuse? I would say yes. So obtuse based on that. What about side lengths? No numbers whatsoever. They're all different. 1, 2, 3. They're all different. So scalene. All sides are not congruent. You can go like this. You survived, eh? Okay, one last one. Can you figure out this one? You've got two, absolutely. So that one is 180 minus the 90 minus 45. That ends up being 45. You probably already did the math here. So if at all possible, try to find all angles if numbers are provided. So here we go, name and first name, last name. In terms of angles, this one is immediately going to be a right. Right. Yeah. In terms of angles, side lengths. I don't know, I don't have sides, Mr. Dirksen. Remember, if you have all three angles, you have that information. These two angles have same measures of the side length across from them. I can guarantee you that. It's a neat property about triangles. Okay, so this is going to be isosceles. Think about it. It cannot be scalene because if two angles are the same, it tells you two sides are the same. Even if you didn't put the markings on there, you should have been able to come up with that. Okay? Okay. Your homework, your mission, should you choose to accept, is, I have a bunch here, hold on. I have some that are a bit harder. We're going to leave those for now. All the way to page 12. You're like, what? It takes you less than a minute to classify. So I'm going to say pages 8 to 12. But before we do that, I'm going to reverse this. Okay? 8 to 12 is your homework. We're going to go to page 11 and reverse this. What if I gave you a name? What if I gave you a name and says, hey, make me a sketch of this? Page 11. I will do 2. Okay, I will do 2. The rest are yours. Page 11. Acute scalene. What does this tell me? All angles less than 90. That's one of the criteria I need to meet. All angles are less than 90. Scalene, all sides different. Hold it. You know what else it tells me? All sides are different. What does that also tell me about angles? All angles are different. That's correct. So it tells you more than just side length if you pay close attention to it. How will we make this work? I honestly don't care too much about what it looks like. I do want to like a slanted roof, a roof that isn't symmetric. That's what I do. The only thing you have to be careful is make sure that the numbers add up to 180 when it comes to angles. So you can try like make this 80 degrees, make this 70. What's 80 and 70? That adds up to 150. So this has to be 30, correct? So you've met the acute part, and technically you also met this part, because all angles are different, all sides are different. But I like to go one step further and just go, this one is different than this one, which is different than that one. They're all different. So I kind of add markings in there. You could also add numbers if you wanted to. So let's say, I would be careful with numbers. Just don't do numbers if you don't have to for the side lengths, because if they don't jive, if you solve this triangle, it doesn't add up to that, then you're in trouble. Okay, so just leave it like that. Yeah, go ahead. One more, obtuse isosceles. Obtuse, one angle greater than 90. That's what that is saying. Isosceles, two sides that are the same, correct? But what else is it telling us? Two angles that are the same as well. It's kind of, I know it's weird, but trust me, it is true. Okay, I might use GeoGebra one of these days. It's like an app that I can use and tweak things, and you'll see that it's true. So how do you do this? My classic greater than 90 is starting like this. Like this is my greater than 90 angle right there. But you have to have two sides that are the same, so kind of try your best. I'm going to try to make these two the same. I'm going to go across like that. So I'm going to make this, I don't know, let's make this 110. So if you use 110, these two have to add up to 70 combined, right? They're going to be the same. So 35 and 35. And I'm just going to go marking, like that. There you have it. Check if sum of triangles equal to 180. That's the one thing I'm going to be picky on. You can't just come up with random numbers and it doesn't add up to 180, or it goes more than 180, then you're in trouble, right? So that's where I'm going to leave it. So pages 8 to 12 is on you.